Now let's create the strands that hang between the different ring layers. First, we're going to build our crystal that's going to be placed along that strand. So let's go up to the top here, kind of outside of our network tree that we've been building. Drop down a sphere, set the primitive type to polygon, set the Z radius to 0.5, and the uniform scale to 0.05. The default unit scale for Houdini is in meters, so we want this to be relatively small. Connect a null node and name that null upper crystal. We're going to be referring to this null node lower on the tree, so make sure you name that. And I would recommend putting it in all caps. It makes it easier to find. Now let's build the strands. Let's move back down. Connect a point wrangle to your copy node and move it to the side to start a new branch of your network. Let's name this set ID. And we're going to add the following expression in here. I at ID equals vertex prim index, 0 for the current geometry, and then at VTX vertex number. And we're going to look at the geometry spreadsheet really quick to see what this is doing. So to compare side by side, I'm going to just create an attribute called VTEX test. Whoop, I did not type any of that the way I wanted to. I at VTEX test equals VTEX number. Okay, so at VTX num is a variable that you can call in a wrangle, same as point num or prim num. It's just a way to reference the current vertex number. If you call vertex number on its own, it's going to give you the vertex number relative to all the vertices on the current input. So in this case, that's just the same as point numbers. What we want is we want to have an attribute that tells us the vertex number per primitive. So, 0, 1, 2, 0, 1, 2, 0, 1, 2. The reason we're doing that is because we want to have an ID number that can tell us which points we should be connecting here. So like we want all of those to be a strand, and we want all of those to be a strand, and all of those to be a strand. And if we use this vertex prim index, what that does is it takes a vertex number and it converts it to its primitive vertex number. So here we now have 0, 1, 2, 0, 1, 2, 0, 1, 2, which is exactly what we want. So we can delete that other line and we can just keep our ID there. Connect a null after that. We're going to name that upper circle prims. We're going to refer to that a little bit later. And now we're going to iterate over each primitive to build its connecting strand to the next primitive. So drop down a for each number. And we want the number of iterations here to be driven by how many primitives we are getting in our input. So we can drive that with an expression. So here on the for each end, on the iterations, we can use the n prims expression. And then we're just going to refer directly to that null that we just created. So upper circle prims. Now what we're doing in this loop is we're going to be looking at each ring and then looking at the next ring and then building the connections between them. So we don't want to do this on the last ring because the last ring has nothing for it to connect to. So we actually want to stop this one shy of getting to the final ring there. So we're going to subtract 1 so that it doesn't iterate over that final ring. And we can name these real quick. I'm just going to call this for each ring begin, for each ring end, and then I'm going to name this for each ring metadata. Now the begin is currently set to fetch input, which means that every iteration it's going to pull in this entire input. And we want to isolate just the current layer in the loop. So to do this, let's drop down a blast node. And we want to select the prim number that matches the current iteration of the loop. If we look at the attributes on the metadata node, you'll see that there's a detail attribute called iteration. We can refer to this to get the current iteration number. On your blast node, add a spare input here. That's going to add that at the bottom. And drag the metadata node over. And now we can refer to that. We're going to use a detail expression. And with a spare input, we can refer to this node using -1. And then we can tell it to look at the iteration attribute. And detail expression also just wants a default value in case it can't find anything. So we're just going to say 0. That's fine. And then wrap that in backticks. Change that to primitives and delete non-selected. Sorry, primitives and delete non-selected. There we go. Now we're isolating the current ring. We also want to isolate the next primitive. So hold down Alt and click and drag to make a copy. That's basically the same as copying and pasting, just a faster way of making a duplicate of a node. And let's add 1 inside those backticks. So now every iteration, we're isolating the current ring and the next ring. Just to keep this clear, let's call this isolate current ring, isolate next ring. And now let's merge those together. Make sure that the current ring is in the first input, and then the next ring is the second input. And now we want to know the distance between these two for our connections. We can get this easily using a little expression. So let's put down a point wrangle. And we're going to create an attribute called height. And we're going to get the height using get bbox_size. So this is an expression that we can give it a geometry input. So we're going to say 0. So it's just looking at the entire geometry. And it's going to return a vector of the x size, the y size, and the z size. Now we only want the y size because we're only concerned with the height. So we can say .y. And that will give us an attribute that gives us our height. Now drop down an add node. And we're going to toggle this delete geometry but keep the points, which is pretty self-explanatory. It deletes all the geometry but keeps the points. And then go over to this polygons tab, go to by group. And when you toggle the by group tab, it builds a curve using all of your points. But we don't want it to use all points. We want it to add by attribute. And we're going to use that ID attribute that we created. So now each unique ID value is getting its own curve. At this point, we're going to temporarily flatten these curves. Now, if we template this is building correctly. It's connecting these two endpoints, but we're going to undo that for a moment by putting down a transform. And we're going to flatten this in Y. So we don't want the pivot to be 0. We want to scale these down to the bottom of their Y values. So we're going to use $ymin as the Y component of our pivot translate. And then we're going to scale this down to 0 so that it flattens. Now at this point, let's resample the curve so we have a bit more detail to work with. So just drop down a resample, and you can just leave it at 0.1 for now. That's fine. Next, we want to make an attribute that's going to tell us how far along the curve every point is. And we can do that by generating UVs along the curve. And we're going to use a UV texture node for that. So drop down a UV texture, visualize it, and set the texture type to arc length spline and the attribute class to point. And what this does, I'm going to quickly visualize our UV attribute. Change it to a marker. So we can see it's a two-vector component, or two components in the vector. We don't care about the y component. That's always going to be 0. But you can see the beginning of the curve is always 0, the end of the curve is always 1, and every other point gets a value telling you how far along the curve it is. And that's going to be helpful for using to remap the shape of our curve. Now this is going to be, if we go back to the UV texture node, this is going to be a some settings we're going to use quite a bit for the UV texture, so it'd probably be a good idea to go ahead and save it as a preset. So to do that, click on the gear, go to Save Preset, and I would name it UV Along Curve, something like that. And you can just save it to the Houdini user pref directory. That's just going to save it to your default user prefs. You can save preset. And now anytime you put down a UV texture, you can click on this gear, and there's a UV Along Curve preset at the bottom that you can select. Now we're going to use those UVs to control the shape of the drooping of our curve. So let's put down a point VOP, connect it to the UV texture, visualize it, and jump inside. So let's grab the UV value. I'm going to make this a little bit larger so we can see. Let's grab the UV value that we just created and use it to drive some stuff. So the UV attribute is available on the global inputs over here. But we only want that X component, remember, because that Y component didn't do anything. So let's put down a VOP called get vector component, connect it to the UV, and we can just leave it to component 1. That'll get the X component, which is what we want. Next, put down a multiply node, and we want to multiply this by that height parameter that we made, or that height attribute that we made earlier. Now, to pull in an attribute that isn't available on the globals, one way to do that is to put down a bind node. We can change this to height, and now per point, it'll pull in the height attribute of that point. Let's connect that to the multiply as well. And we only want this to affect the heights of our points, so it's only going to apply to the Y vector. So let's put down a float to vector, and connect this to float value 2 there, which is going to be Y. So our X is 0, our Z is 0, but our Y is going to be this. And let's add this to our global P. So add global P over here, add this, and then output it to our P. So now, when our UVs are 0, it isn't transformed at all, and when our UVs are 1, it's transformed all the way up to the proper height. But you'll see here, it's backwards. That's because our UVs just happen to be backwards in this case. That's an easy fix though. We can do that right here in the VOP by using a complement node, and we can drop that after the get component, vector get component, and that'll flip it around. What a complement does is it takes the input and it subtracts it from 1, see, 1 minus whatever. And in the case where we have a 0 to 1 value, like we did with our UV, it basically just inverts the range for us. So now we're right back where we were before we flattened the curve. So you might be wondering why we went through the trouble to recreate this in VOPs. And the reason is because now that we have this rebuilt in VOPs, we can more easily reshape the curve however we want. And we're going to do that using a ramp parameter. So after that complement we put down, select these, move this over, put down a ramp parameter, and make sure we connect it there after the complement. Let's name that droop ramp. Let's set the label similar. Change the ramp type to spline ramp. Now let's hop up a level. And you have 2 points by default. And let's move it. You may have had it reset your values like mine just did. So if it did, grab that last point, drag it all the way up. And click this point, and then hold down Shift and click that first point, and change the interpolation to B-spline. That'll make sure that both of them are changed. And now that you've got that set, you can kind of play with this, and you can shape the droop over here of this curve. And this is going to be the curve that we're going to have some crystals on, so you can get something kind of nice looking. We'll go with that. And let's name that shape droop. And at this point, we can copy our crystals onto the curve. So to keep our network organized, so we don't have wires kind of flying all over the place, let's put down an object merge. And let's merge in that upper crystal we made. I'm going to name that in upper crystal, make it blue. And then we're going to put down a copy to points node, put the crystal into the first input, put the curve into the second input, and visualize it. You'll notice that our crystals are flat. They're not orienting along the curve. That's because we haven't added any attributes to our curve to tell it how to orient itself yet. So to do that, we're going to put down an orientation along curve and connect that. Before we get into that though, let's take a look at how this normal and this up are going to be affecting our copies. So don't worry about following along for this part. I'm just going to hop over to a different part of the network here. So over here, I just made a small little cone, and I have its tallest side is pointing up in Y, and then if you look from above, its second longest side is pointing along the Z axis. And over here, I made a point. It's pointing up in Y. The normal is pointing up in Y, and then it also has an attribute set to up. So its normal is pointing up in Y, and its up is pointing along the Z axis. So if we template this, we can see that wherever the up vector is pointing is where the y-axis of the source is going to align. And whoops, let's go back over here. And wherever the normal of the source point is aligned is what the z-axis of the incoming geometry is going to align to. So if I go here and I start to modify this, you'll see that as I rotate my normal, it continues to align, don't translate it, continues to align with the z-axis of the incoming geometry, and same with the up and the y-axis. So you'll just want to keep that in mind as you're creating your normals and your ups and trying to figure out how to make those relative to how you aligned things here. Just keep it so that the front of your object is along the z and the top of your object is pointing up in y, and then use your normal for your front and your up for your y. So let's hop back over to our crystals here. So with that in mind, let's name this set up and n. Visualize our normals here. And we want the normals to be along the curve. So this is great. And we want our up to be pointing kind of up this way. So I can see if we, or the inverse of that is fine as well. So the x-axis is what we want for our up, and then the z-axis is what we want for our normal. So now if we go back and visualize this, you'll see that they are rotated. Sorry, I had those flipped. The normal along the x-axis, and there we go. So now these are oriented the correct way, but the distance is incorrect. The distribution is wrong. So we need to fix that. So let's go back to our resample node here, add a spare input, and reference in our upper crystal. So what we're going to do is we are going to set the resample spacing to be equal to the height of our crystal. And we can do that by using this bbox expression. So we'll do bbox, and then we'll use -1 to refer to our spare input. And then down here, you'll see the way this works is you say bbox, and then you point to a node, and in this case, we're pointing to our spare input, and then type. And the type can be xmin, ymin, zmin, xmax, ymax, zmax, or the x, y, or z size. So we want to get the y size. So what we're going to do is we're going to put this weird little d underscore y size in all caps. And you don't need to put that in quotations or anything. It just knows what d underscore y size means. And so now it's going to resample that based on the height of the crystal. But if we go down and visualize this, we'll see it's still not really working properly. And the reason for that is because the length of our curve is changing during this shape droop. And oh, I apologize. I put this in the wrong spot. This should all still be in the for each loop. So going back to where we were. If I bypass this, you can see it is working properly. So we need to have that resampling happening after this shape droop, but we want to make sure we're resampling with enough fidelity to be able to add this curve, because if we bypass that resample, we only have 2 points. So to do that, let's just right-click this resample and say create reference copy. And you'll see it's got this little blue description now, and it just made a copy with every parameter linked to this. So this is basically just exactly the same as this node. And let's drop that down after the shape droop, and now everything is distributed properly. Let's add a little bit of variance to this though, so they're not all perfectly straight. So after this orientation along curve we added here, so right before the copy to points, let's add an attribute randomize. And what we're going to do is we're going to randomize that up that we set so that our, or actually no, we're going to randomize the normal so that the face of the crystals are randomized a little bit. So let's set this to n, and let's set this to -1, -1, -1, and we don't want to override the normal, we just want to add to it. So what we're saying is add a random value between -1 and 1 to every component of the normal vector. And -1 to 1 is pretty strong, but we can control how much of an effect it has with this global scale. As you can see here, if we look over here, we kind of get a little bit of extra variance there. So lastly, let's promote some of these parameters to our control node. So I'm going to drag this control node down and open the parameter interface for it. I'm going to make a new folder, and I'm going to call it upper. Make that simple. I'm going to add upper rings to that, and then I'm going to make a new folder in upper, and I'm going to call it upper strands. Make it another simple. Now you want to double check something on your parameter interface, because what we're going to do is we're going to click and drag some parameters that we want to just directly link in here. And sometimes Houdini doesn't like that. So just to make sure that it does, click on this gear and make sure that this forbid linking parameters from outside the subnet is not checked. We want that unchecked in order for this next part to work. Now let's go back to our attribute randomize and click on the global scale and drag that into upper strands. And let's name this crystal angle variance. Actually, let's name that upper crystal angle variance. And then the name can just be crystal angle variance because it'll be in the upper folder, so we'll know that it's there. We're just also going to create one of these for lower later, and so this will help us distinguish those. Let's change the range to 0 to 1. Now keep this open and select your shape droop node and drag the name, hover over the name droop ramp and drag that into the folder as well. And the name of that is fine. We like that already. Let's press apply. And then lastly, we're going to create a parameter here. We actually are going to add one more node. So above the for each loop, right before the set ID node, let's add another resample and turn off maximum segment length, turn on maximum segments, and then drag that parameter into our upper strands. So reopen parameter interface if you closed it. And we're going to name that num of upper strands. And then you can click accept. And at the very bottom of all of this, after the for each loop, let's put down a group. And we're going to change the group name to crystals, except spelled correctly. And we'll call this group crystals. And let's update some of our names. Let's make this copy upper crystals. We'll call this randomize n. Oops. We'll say resample to crystal height, add UV, that's also resample to crystal height. There we go. This is going to be flatten in Y. Build curves. Set height. There we go. Everything's nice and labeled. Can delete this visualize. I don't need that anymore. I'm going to select all of these. Press Shift L to make them nice and pretty and laid out. Let's do the same thing with this. And then what I'll do as a final thing to keep this organized is select all of this, put it in a network box, and label it upper crystal strands. And now those are done.